Alright, let's work through this right triangle problem carefully, step by step, and make sure every part of the algebra makes sense. We have a right triangle PQR, and the three side lengths are given in terms of m. One leg is m, the second leg is 4m squared, and the hypotenuse is 9m cubed. Our job is to find the value of m. Before we start, if you find this type of algebra and geometry problem useful, take a moment to like the video, subscribe to the channel, and let me know in the comments if you were able to predict the answer before we finished. Now let's focus on the mathematics. Because triangle PQR is a right triangle, the natural theorem to use is the Pythagorean theorem. Remember, the Pythagorean theorem tells us that the square of one leg plus the square of the other leg equals the square of the hypotenuse. In spoken form, that is, leg 1 squared plus leg 2 squared equals hypotenuse squared. In our triangle, the first leg is m, the second leg is 4m squared, and the hypotenuse is 9m cubed. So let's substitute all three expressions directly into the Pythagorean theorem. We get m squared plus the quantity 4m squared whole squared equals the quantity 9m cubed whole squared. Now, let's simplify these powers carefully. The first term, m squared, simply stays m squared. For the second term, we have 4m squared being squared. When we square the 4, we get 16, and when we square m squared, we get m to the 4th power. So this entire term becomes 16m to the 4th. On the right-hand side, we have 9m cubed being squared. 9 squared is 81, and m cubed squared becomes m to the 6th power. Therefore, our equation becomes m squared plus 16m to the 4th equals 81m to the 6th. Now, we want to bring everything to one side so that the equation is equal to 0. We can move m squared and 16m to the 4th to the right-hand side, or equivalently move 81m to the 6th to the left. Following that arrangement, we get 81m to the 6th minus 16m to the 4th minus m squared equals 0. Now pause here and look at all three terms carefully. We have 81m to the 6th minus 16m to the 4th minus m squared. Every term contains m squared, so m squared is a common factor. That means we can factor m squared out of the entire expression. When we take m squared out of the first term, 81m to the 6th becomes 81m to the 4th. From the second term, minus 16m to the 4th becomes minus 16m squared. And from the final term, minus m squared becomes minus 1. So our factored equation is m squared multiplied by the quantity 81m to the 4th minus 16m squared minus 1 equals 0. Now, when a product equals 0, we use the zero product property. This property says that if two factors multiply to give 0, then at least one of those factors must equal 0. So we have two possibilities. The first possibility is m squared equals 0, and the second possibility is 81m to the 4th minus 16m squared minus 1 equals 0. Let's deal with the first possibility first. If m squared equals 0, then taking the square root of both sides gives m equals 0. But we have to think about what m represents. M is being used to describe the side lengths of a triangle. A triangle cannot have a side length of 0 because that would collapse the triangle and it would no longer be a proper triangle. So m equals 0 is not physically acceptable here, and we reject that solution. That leaves us with the second equation. 81m to the fourth minus 16m squared minus 1 equals 0. Now notice something very important. This equation contains m to the fourth and m squared. That might look like a fourth degree equation, but we can make it much easier by using a substitution. This is a very useful algebra technique whenever we see a variable raised to the fourth power together with the same variable raised to the second power. Let's define a new variable. We'll say u equals m squared. Now, if u equals m squared, then u squared equals the quantity m squared whole squared, which is m to the fourth. So m to the fourth can be replaced by u squared, and m squared can simply be replaced by u. Therefore, our equation 81m to the fourth minus 16m squared minus 1 equals 0 becomes 81 u squared minus 16 u minus 1 equals 0. Excellent. We have transformed the complicated-looking fourth-degree equation into an ordinary quadratic equation. Now we can solve this using the quadratic formula. Remember, for an equation of the form au squared plus bu plus c equals 0, the quadratic formula is u equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now compare our equation. 81u squared minus 16u minus 1 equals 0. With the standard quadratic form, we can identify a as 81, b as negative 16, and c as negative 1. Let's substitute these values carefully into the quadratic formula. We get u equals negative 16 plus or minus the square root of negative 16 squared minus 4 multiplied by 81 multiplied by negative 1, all divided by 2 multiplied by 81. Now let's simplify this step by step. First, negative 16 becomes positive 16. Next, negative 16 squared is 256. Inside the square root, we therefore have 256 minus 4 multiplied by 81 multiplied by negative 1. Since 4 multiplied by 81 is 324, and multiplying by negative 1 gives negative 324, subtracting a negative 324 is the same as adding 324. So the expression under the square root becomes 256 plus 324, which is 580. Therefore, we have u equals 16 plus or minus the square root of 580, all divided by 162. Now 580 can be written as 4 multiplied by 145. The square root of 4 is 2, so the square root of 580 becomes 2 square root of 145. Therefore, u equals 16 plus or minus 2 square root of 145, all divided by 162. We can divide the numerator and denominator by 2, giving u equals 8 plus or minus the square root of 145, all divided by 81. So we have two possible values for u. The first is u equals 8 plus the square root of 145, all divided by 81. The second is u equals 8 minus the square root of 145, all divided by 81. Now we have to determine which one is actually possible. Remember, u was defined as m squared. Since m is a real side length, m squared cannot be negative. Let's estimate the square root of 145. It is approximately 12.042. Therefore, 8 minus the square root of 145 is approximately 8 minus 12.042, which is negative 4.042. That would make u negative, and that is impossible because u equals m squared. So we reject the negative option and keep u equals 8 plus the square root of 145, all divided by 81. Now we return to our original substitution. We said u equals m squared. Therefore, we can replace u with m squared and write m squared equals 8 plus the square root of 145, all divided by 81. Our goal is m, not m squared, so we need to undo the square. We do that by taking the square root of both sides. Therefore, m equals the square root of the quantity 8 plus the square root of 145, all divided by 81. Since m represents a positive side length, we take the positive square root. We can simplify this slightly because the square root of 81 is 9. Therefore, the final exact value is m equals the square root of the quantity 8 plus the square root of 145 divided by 9. Let's also calculate the approximate decimal value so we have a better idea of its size. The square root of 145 is approximately 12.042. Adding 8 gives approximately 20.042. Taking the square root of that gives approximately 4.471. Dividing by 9 gives approximately 0.497. So m is approximately 0.497. And remember, we should always be careful with approximate values because the exact form is the more precise mathematical answer. Therefore, our exact answer is m equals the square root of the quantity 8 plus the square root of 145 divided by 9, and its approximate value is 0.497. Notice how the entire problem was really a combination of geometry and algebra. We started with the Pythagorean theorem, substituted the algebraic side lengths, simplified the exponents, factored out the common term, rejected the impossible zero solution, introduced the substitution u equals m squared, converted the equation into a quadratic, applied the quadratic formula, rejected the negative value because a square cannot be negative, and finally took the positive square root to obtain m. If you followed all the way through, make sure to like the video, subscribe for more challenging algebra and geometry problems, and leave a comment telling me which step you found the most interesting.